everyone, I'm in Precast Yard and I'm going to show you something interesting and very technically and related to geometry controlling of these types of grids. This precast factory built up for several projects here, but all of them are balanced cantilever. So we got only two types of segment here. One of them is standard segment, which you can see here. You got a big hollow inside it, and it's lighter, I think around 30 tons. And the other type is Pier segment, which is solid and more heavier. Here you can see it's about 60 tons. And basically the Pier segment sits on pillars and other standard segments connecting to this one from forward and backward using pre-stressed cable. Anyway, if you can see here, the thickness of bottom of segments is constant, and also Pier segments formerly was like it. And when they want to erect the Pier segment on pillars, they have to adjust it to achieve the slope, the two slope on two perpendicular axes at top of segment, which I gave them some coordination to achieve those slopes. And after that they put a neoprene, they put a pair of neoprene beneath the segment and the rest of the work. But this procedure, I mean the erecting Pier segment on pillars like that was very dangerous because they have to work beneath the segment in a small area of column, and it lasts a long time. Maybe 4 days they have to work to achieve those coordinates I gave them. So recently we changed the design and we decided to do something like this. If you can see this Pier segment, the slope executed beneath the segment, and also it is in two axes. If you can see that one, that's for abutment. If you can see, all in two perpendicular segments, it got a slope. And if you got something like it, when you put it on flat surface, this is what we got. The slope automatically achieved in two directions, and it's more, and it helped the company because it let the work to be faster, because you need only a crane to put it on neoprene. Just you have to flat the neoprene and put the segment on it in correct XY direction. You shouldn't to rotate it, and this caused the work going faster and also cheaper, because you just only need a crane to put it on and nothing else. But the problem is it made the geometry control more risky, because they have to execute the slope very carefully and very accurate, but also they couldn't, because here we're facing with material like concrete, and they couldn't access correct slopes. For example, for this one, I remember I gave them the slope for 6%, but they gave me 6.3%, and the slope of Pier segment executed on all other standard segment of the span. So the other problem for me was to finding a solution to measure how the accurate slopes are executed to correct the rest of segment in correct project line and super elevation. And we recently finished a project with this method. It was our first project with this type of method. Of course, no critical problem occurred, and the project I'm gonna put picture here. The project has just opened about a week ago, but they gave me huge library of experience about it, and for this new project and the other project, and I'm gonna put the image of them here. We're going to use this type of method with huge experience, and this one let us be faster and working more cheaper to get better profits. Thank you very much.